Hey everyone, welcome back to my channel. This is Vikas Singh Thakur. In this video, we are going to understand the basics of ESP32. We are going to program it, and we will understand the basics of the programming part. So if you are someone who is starting from the scratch, then you will understand the basics of the programming. I understand nowadays everybody is going with the ChatGPT, Claude, or other AI based coding. But believe me, if you understand the basics part, then if you are getting some output from AI, then you can manipulate it based on your requirement. And if you are just randomly throwing some prompts and getting the output, well, it's all the output is all that matter for us. But when we are going into higher level, then it is very important for us to understand that what is going behind all those programs that is generated by AI. So it is very important. So without any further ado, let's get started and let's see the basics of ESP32 hardware first. So now let's understand the basics of ESP32 board and let's see what are its feature and what are its pin and which pin you should use and which pin you shouldn't. You should be very careful about. So first thing is starting with the ESP32. This is the ESP32 board. So ESP32 board is manufactured by Asperif. Well, the chip here you can see on top of it. So this part is by Asperif. Silicon Lab is something that I know. And here it is one of the most widely used development board in modern robotics, IoT, Internet of Things, automation, drones, smart devices. A lot of the AI-based embedded system are also using this exact board. So you can see here, unlike traditional microcontroller that only execute program, ESP32 can also simultaneously process data, and it can also communicate wirelessly. So we are getting the Wi-Fi plus Bluetooth with this. So Wi-Fi plus BLE, that is Bluetooth Low Energy. So this is important thing, that the reason I choose ESP32 instead of going with the Arduino, because if we are going with the Arduino, then we will be needing extra module to get this feature, that is the Bluetooth and the Wi-Fi part. So instead of just buying those extra hardware, it will cost us a lot. So we are going to directly go with this one. So almost the pricing is almost same. Even most of the Arduino are much costlier than this ESP32 board. And another reason the reason I am going with this is the number of pin. So we are getting higher number of pin, we are getting more number of GPIO pin and PWM pins through which we can control motors or other servo motors kind of thing. So this is what a better part of an ESP32 is. And here we are also getting wireless communication, real-time sensor processing, computer vision integration we can also do. So these are kind of projects we can work on. So if you want to develop an mobile app through which we were to control our RC car or something like that. So some of the hardware features that I want to list here are as follow. So here we got, first thing is the dual core extensor, dual core 32-bit extensor LX6, sorry, LX6. So we got 32-bit of resolution. So we are getting a better resolution compared to the Arduino. And we also got the dual core, which make the overall processing block in two processing block would be there. And next thing is the processor. So here we when we are talking about the processor, so dual core 32-bit extensor is there. And when we are talking about clock speed, so clock speed in the hardware defines a lot of things about its capability to do something. So in the ESP32 we got a clock speed of 240 megahertz, which is really crazy. If I'm talking about Arduino UNO, then it got 16 megahertz. Just look at the numbers. So 16 to 40, it's more than triple or four times. So this is very important, and I could say one of the best thing I could say here. So clock speed is 240 megahertz. And when we are talking about SRM, that is static random access memory, that is SRAM. So in the ESP32 we got 520 kilobyte of SRM. So 520 kilobyte of SRM. And if I'm talking about Arduino, then we got 2 KB. So which is really less in Arduino. So this is really huge difference, I could say. And you can also see the clock speed is very high. And next part is the flash memory. So in the ESP32 we got a flash memory of 4 MB, 4 megabyte. So we got flash memory of 4 megabyte. And if I, just for comparison, if I talk about Arduino, then we got 32 KB, which is really less. And here you can see the the difference in the numbers, so KB and MB. So here after the flash memory, the operating voltage, here the operating voltage will range from different board to board. This board here can operate in 5 volt, and most of the the low cost board could also 32, which can also operate on 3.3 volt. So if you're working on some projects where low power is there, or you are building some solar power based, or some remote servers, or something like that. So if you want to do some IoT based project, then you can go with the 3.3 volt, because a lot of the sensors support 3.3 volt, and we don't actually require 5 volt a lot of time. So if I'm talking about the pin, then the digital pin or digital GPIO pins, so total digital GPIO in our ESP32 we got total GPIO of 34. So some of these pins are not actually good to use, or not recommended a lot of time. So here, sorry, I just want to check whether it is recording or not. So the digital GPIO is 34, and some of the pins here are not actually recommended to be used. So I will tell you exactly which are the pins that you should not be using. Next is, after the digital pins, the analog pins, which is up to 18. So when we are talking about the analog pins, through which we can take the analog values, or just get some of these analog values, like moisture sensor or different sensors, which gives us the analog value. So if we are talking about analog pins, then there are 18 pins. And these numbers here, the 34, 18, these are actually something that could vary board to board. So if I'm going with ESP32 Java board, so that is also an ESP32 family, or I could say the overall inheritance of this ESP32 board. So they have lesser number of pins. So you need to look at the particular board, which whatever you are choosing, and based on that you can check the data sheet, what are the number of pins, and different features are there. So you can check it out. And when we are talking about PWM pins, so here one thing is that when we are talking about pulse width modulation, so PWM is something I will explain you in a very detail when we are talking about DC motors or servo motors. So PWM, the number of PWM pin is almost all. So we can use all of the pins in the ESP32 almost. I will explain you, some of the pins are not actually compatible, but almost all pins could be used as a PWM pin. And next thing about which pin to use and which pin to be, you should be very conscious, or very cautious about. So the pin number from 11, 10, 9, 8, and 7. So this and also 6 one. So these 6 pins are something that you should be very cautious about this, because these are connected with the SPI flash memory. So you should be very aware about this, using this pin, because most of the time it happened that we have made all the connection, and some sensor, some response is not proper or not good at all. Or if there is something, once we programmed our ESP32, sometime it happened that that particular pin is not functioning that good, or when we are actually starting it, it's not even booting up. So this could be one of the reasons. So these 6 pins are something you should be little aware about, or a little cautious about. And you can check the exact pinnings that you should be using in the link on the description. So they have already explained a lot about the actual pin that you should be using in an ESP32. So there are different communication protocols that ESP32 can support. So first one is the PWM. I have already told you, pulse width modulation. Mostly we use PWM for motor control, servo control, and we will be using this a lot in our robotics project, or when we are talking about RC car or some autonomous robots. So we will be using this a lot. So PWM is something that it supports UART, that is Universal Asynchronous Receiver and Transmitter, We'll be also using this when we are talking about communication with different other microcontroller, or when we are talking about communication with other some kind of sensors. So this will be used. Next is I2C, so inter-integrated circuit, or mostly we write it I2C or I2C. So inter-integrated circuit, these are very common kind of communication protocol that is used in industries also. So we will be using this communication protocol a lot of time in OLED display, or when we are talking about liquid crystal display. So they are using this kind of small module which reduce the overall number of pin that you needed to connect with your microcontroller. So we'll be using this, and I will explain all of these protocol in a very detailed way in another lecture. So we'll be looking into it, and what are the half duplex, full duplex, a lot of concept would be there. So we'll be understanding this. Next is SPI, that is serial peripheral interface. After this, we also got I2S. So we'll be using this in some of the output devices sometime. And after this, we also got ADC and DAC. So that is analog to digital converter and digital to analog converter. So these are some of the communication protocol that ESP32 can support here. And you can use this protocol to either communicate with your servo motors, different microcontrollers, other sensors, other boards, or even your computer. So we'll be using this different features here. So based on that, we will be doing some of the experiment around the ESP32. So this is very important. These are some of the communication protocol that you should be knowing about, and I will explain all of these communication protocol in our lectures. So be with me, and these are all the features, or these are all the hardware features about ESP32. Now, without any further ado, let's get to our system and let's set up our ESP32 with our computer, and we'll be installing Arduino IDE and setting up our ESP32. So first you need to go to any of your browser to install Arduino IDE. Just search for Arduino IDE install, and inside that you will find a quick link for Windows, Mac OS, Linux for your latest version. Once you click on the link, it will start the downloading automatically from its side, and it will once it's downloaded, you just need to open it from your home page, or just search for it and open it in your system. So I already have the Arduino IDE installed in my system, so I'm going to open my Arduino IDE. So here we got our Arduino IDE installed in our system, and once we are here, you will most probably find your new page, something like this one. So you will find a new page here. So here you will find void setup, void loop, some different functions all around here. So these are actually workspace. So first we need to set up our ESP32, which is this board here with our system. So first you need to go into the file. So these are the steps that I will be telling you. So first go to the file, go to the preference. Inside the preference, you will find an additional board manager URL. So in this, just click here, this point, at this copy point, and inside you need to paste this particular URL. You can find this exact URL in my description, and you just need to paste it here. And once it's done, click OK, and then again OK. It will download some small packages around in your, in the Arduino IDE of yours. And once it's done, you need to go into the sketch. Inside in the tool you need to go into the board. You will find it somewhere around here, and in the board you need to select board manager. In the board manager, there are multiple option or multiple different boards that you can install a package for, and all of these different boards have different manufacturers. They have already pre-built all of these different things around it, and you need to just install ESP32. So search for ESP32. You will find two of this option. You need to go with the ESP32 by Asperif system. So I have already installed it. You need to just click install up to here. So this is the newer version. I have 3.37, and you can also go with any of the brand new version if you have at that time. So it's not going to affect our overall course or flow here. So just install it, and you need to wait for it quite a long time, because it requires a good amount of internet, because it's a very high size package here. So once it is installed, you just need to go into the tool. So first you need to attach your ESP32 with your system. So get your micro USB cable and power your your ESP32 with your cable, and you will find an red light glowing into the red LED glowing in your ESP32 on top of your ESP32. Once you are done this, go to the board again, and you will find an extra option of ESP32 in the ESP32. And once you click the ESP32, you will find there are multiple number of variants or different boards boards option are there. So you need to select the particular board that you have. For example, I have ESP32 Room DA. And if you are confused about your board, then I would suggest try to select one or two boards, like just do trial and error. So ESP32 dev module is something you could try, then ESP32 Room DA or Brewer. So most probably if your ESP32 look like this one, like my ESP32, then you should be also selecting the same one. Most of the time it works, but if it didn't, then you need to try multiple boards here and you need to check which one is working. So ESP32 Room DA is something that I have, so I will select it. And after this, again go to the tools, and just below the board you will find port. So in the port you will find a particular COM port which is being detected by our system for my ESP32, for example. And if you are getting multiple of the COM port here, you just need to unplug and replug it, and you can check which one is disappearing and reappearing. So that is the actual COM port. You can also go with your device manager and you can actually check out the exact COM port that your ESP32 is connected. So here you can see Silicon Lab CP210X USB to UART bridge. So you need to just check here and select that particular COM port. Here one troubleshoot and one problem that most of the people also found is that their board is not visible here. So what you can do here is just go to the tool. When your COM port is not visible here, what you can do is in the device manager you will find that it is in my device manager. So here you can see the Silicon Lab CP210X USB to UART bridge. So actually you need to install a driver for this. So I will put a link on the description. You can go to that particular link and install that driver. Actually that driver is CP210X that convert USB to UART. So this driver help your system to identify your particular ESP32 or other boards. So most of the time it also happen with Arduinos also, not the official one but mostly the clone one. So you need to install that, and once it's done, you just need to go to the board and you will find your ESP32 here. So once it's done, this is the overall setup of your ESP32. Let's go to the file and let's upload a very basic example. So here in the file section you will find example option. Inside example there are tons of different script which is already pre-built, and you can use this script in your ESP32 and try out some of the example. So we are going to try out a very basic example. In the basic part, go to the blink here. So which is the I could say a hello world of any ESP32 or any kind of Arduino. So just go there, and inside this you will find a script here. So let me just remove the comments here to make it clearer. So here you will find that a void setup, pinMode, then void loop. Inside this you will find some of the script. If this is the first time for you, don't worry here. I will be explaining all of these in a little detailed way, in a basic way, so that you can get basic understanding of what it is. Just go to the upload button on top of your corner. You will find this arrow which says upload, and just the right mark or the right sign is the verify or the compiling. So if you click on the right button or something like that, okay, so we got an error because this LED built-in is by default targeting to Arduino UNO pin, that is the built-in 13 pin. So we need to remove this, and we have ESP32 which have the built-in LED on pin number 2. So you need to remove it and make it 2. And that's it, and we are now targeting to our LED pin 2 and just upload it. So once it's compiled, you can either compile it. If you want to just verify it, just click this one, and if you want to upload it to your board, then click this arrow. So here it is uploading. You will find something like this, and once it's uploaded you can see the LED is blinking. So it means your code is successfully uploaded and it is on your board. So what this code is actually doing is it is starting your LED for one time and for 1 second, and it's closing it for 1 second, and it is doing it for continuous loop. So this is a very basic example. If all of these are done in your ESP32 till now, your ESP32 is well and done and everything is going fine. Now we are going with a basic example or basic of programming part. We will understand different structures of programming in here, all in the basic way. We are not going into very deep into this concept, but we will be covering all the basics so that the beginners, very beginners, could go with us, and they don't need to understand very much into deeply into this part. When we are working with the application part, I will explain you each line of the code, and we can move on and we can learn together. So first you need to have the Arduino IDE. Just click Control N, and then you will find that a new window will appear, and this is the very fresh window in which nothing has been there. It's completely clean window. Here you will find two of this option. Whenever you are writing an Arduino code or ESP32 code, you will find this two for sure. So what this actually doing, what are this actually doing here is so here you will find this two option here, so void setup and void loop. So in void setup, whatever you put, just get this this in your head, that whatever you put in your void setup, it is declared and it will execute for single time, and whatever you execute or whatever you put in void loop, it will execute that for continuously in a particular loop. So it will do that repeatedly for entire time until unless you restart your ESP32 using the restart button, or if you power off and power on your ESP32, then it will start again. So void setup would have all those part of your code that is required to run once, and void loop would have all those code part that is required to run continuously or for entire time. So void setup, in the void setup we basically do serial initialization. We tell all those things about our board, like pin function, what each of these pins should be working like. So it should be input or output, high or low. So this could be things that we could put in the setup, and in the loop we'll putting all those things which is required to learn continuously over the time. So let me give you a very basic example of what we have just recently done. So just go to the previous code where we have uploaded the LED button. So here you can see we got two of these sections, so void setup and void loop. So inside this we got this extra lines here, which is the extra programming part. So here you can see in the void setup we are defining pinMode to output. What this actually doing is it is initializing pin number 2 to work as an output, and this is a one thing, right? So we are asking our our board to set this pin, that is the pin number 2, as an output, and we are asking it only once, because in void setup whatever we put here, it will ask only once, and this is something that is needed to ask only once. You cannot later on change. You don't really want to change the pin functionality later on. If you want to, you can just hard code it here, but if I'm talking about digital writing high and low, you cannot put this in here, because if you do, it will just execute each of these line one by one, and it will terminate it, and it will not be going to do that in continuous way like this one. So if I put this exact thing, let me do it. So if I, let's say, just example, if I put delete all of those lines from the void loop and I put it in the void setup, and let's see what would happen. So if I put all of these in void setup and I upload this code into my board, and you will see what would happen. So what it do is, once it's uploaded, so let me press the reset button. What it actually going to do is it will turn on the light and turn off the light, and that's it. It's not going to again turn on and turn off. So it will be going to run that particular code once. So I'm going to press the reset button. It's on and off. That's it. It's on and off. That's it. It's not going to repeat that. It's not going to it's not going to repeat the on and off again and again. So whatever we put in on void setup, it's not going to repeat it at all. So once we do this exact thing in the void loop, we have already seen that. we delete it from the void loop, and when we print it, put it back into the void, from void setup to void loop, let's see what it will be going to do. It will continuously run that code again and again. So this is the basic understanding of how void setup and void loop work. So whatever you put in the void setup, everything will execute for once. Whatever you put in void loop, it will execute for forever. So this is what the basic understanding of the basic structure of an Arduino IDE look like. And these are the things that I want to share here. And let's go to the next part, that are variable, very important, because most of the thing we are going to define using variables, they are actually containers. So let's understand what exactly are variables. Now we are going to understand the basics of variable. I have also taken this all this script here, and based on this script we are going to understand, and we are going to see the exact script or exact syntax how you are going to define that particular thing. So in the basic, very understandable way, variable is nothing but a container which contain different type of values inside it. So in your kitchen you have different spices in different containers, right? So in similar way we have variables which have different containers into it, and we put different spices or different numbers, or different categories of numbers or different things inside the variables. So this is the basic I could say an understandable way of understanding what exactly are variables. So they are container which contain different things around. So first variable we have is the integer. So int, we will be defining all the whole numbers. So what integer int do is it store all the whole number. So it could be for Arduino it varies from -3 to 768 to 3 to 767. So this is the value of range that you can store as a whole number inside the integer. So the best example here is, for example, when we are defining an LED pin. So for example, if I want to use my LED pin in the ESP32 as we are talking about, which has LED pin number 2. So we are defining LED pin number in the pin number 2. So using this we can do that. So we are storing this value, that this is the pin number that we want to use in our program, and this is this is how we are storing it. So later on, if I want to use this pin, what I need to call is I'm going to get this box. So it is similar to it is, if I'm making tea, then I want sugar. So I'm not going to get the sugar directly. I'm going to get the container, and after inside that container I'm going to get the sugar, right? So in the similar way, LED pin is a container and 2 is the sugar. So if I want the exact value what is inside that, then I need to get first the container and then I will take the sugar. So this is how the variable works. So it is a container which contains value 2 inside it, and it is an integer container. So it is a kind of sugar container. You cannot put the spices into it. So this is one way to understand it. So this is the int function or the integer variable. So inside this we store whole number. Next one is the long. So in the long we store very large whole number. So integer are there is very limitation with the integer range. So what we have another variable, that is the bigger box, we could say, where we can put large quantity of sugar inside that. So we can put that large amount of sugar in the long container. So this is something you can understand. So it contains large numbers. So long distance. So for example, this is the value I want to store, or we can say there are some password that we want to build here, which is very long. So we can use a long variable here. So inside this we are containing the particular element or particular things into it. So after this unsigned long, so in the unsigned long, what it store only positive large number. So here in the long we can also store negative values, but if we want to be very specific, and if we have a good amount of range in the positive values, then we can use unsigned long to store all the positive values. So for example, if we want to store a current time, that is we are defining it as starting from the 0, then we can do this using unsigned long. After this, the float. So in the float, when we are talking about 3.3, 1.2, 2.5, so all these are decimal numbers, which is not a whole number. For whole we have seen the integer way, but when we are talking about point or decimal values, then we can go with the float. So this is a different container inside which you can put the float. So float stores all the decimal numbers. After this, the double.
So here in the double, we store decimal number with higher precision. So for example, I want to store the value of pi, that is 3.14, and it could go for very longer values. So if I want my system to be very precise, I need to go into higher number of decimals. So the higher number of figures, backward figures. So we need to store, if we want to store higher number of decimal numbers, then we want to go into very much precise system, for example CNC, or when we are talking about robotics arm, or when we are talking about calculating the speed of light, or speed of a certain object, or distance of certain object very accurately, then we can use something like this. So the higher the decimal value, or more the precise the decimal value, we need to go with the double. After this, character, so char, so that is here we store one single character in this. So for example, if I want to build an RC car where most probably all of us have been playing video games in which when we press W, then the car moves forward, when we press S, then car moves backward, A left, D right. So in similar way, if I want to build an RC car where I want to use W as forward, A as backward, S as backward, A as left, and D as right, then I can use character, and I can define that particular key, that this is, when this is pressed, this should be done. So this is one example of how you can use this. So character store a particular character, so char store particular character inside it. So A, B, C, D, E, F, G, whatever you want to, you can put it. But what if we are building, and let's say if we are building a password, let's say I have a password, let's say password is my password. So if I want to store a longer number of character, or longer number of, you can say a number of sentence, or a group of words, then we can use string. So using a string, we can put the name as like this. So for example, path to robotics, then we can store it in the string like this way. So this is used to store multiple character. This is a one of the example we'll be using a lot in when we are going with the server development, where we want to display some text or something like that. So this could be work there. Next is a boolean is I could say it only store true or false. So you can see it either store true or false. So it has only two values, 0 or 1, true or false. So it will be always returning you whether a condition is true, whether a condition is false, or something like that. So it is mostly used in conditional values or conditional things. For example, if there is a object in the front of it, then I can ask directly whether or there is that object or not, for my RC car or for autonomous car. So if there is the value is true, then we are not going to do that. But if value is false, we are going to do that. So this could be a different example or different type of it. And next is byte. So byte, what it do is it stores numbers from 0 to 255. And 0 to 255, let's say in most of our PWM signal, when we are talking about when we are talking about our for example controlling a DC motor, when we are talking about building an RC car, then we are going to go into this range only. So 0 to 255 is something we are going to define the speed in this range. We are going to define the range of our motor speed. So this is where we will be using byte. So for example, byte speed is equals to 200. This is the speed of something that we are actually defining here. Next one is a sort. So what a sort do is So next is a sort. So it is almost same. It has same range as of an int in an Arduino UNO. So you can either, I would suggest go with the int directly, but just for understanding, you can get the sort. So in this, it is almost same as an int or int function or that same container. So the range is almost same. And next one is unsigned int. So unsigned int, as I already told you about, so it is stored all the positive integers. So positive integers, right? So here the value could be ranged from 0 to 65535. So this is the basic I could say the range here. So inside that, let's say we want to count some object, then it is going out to a very any object could not be negative. So we know that that will be always going to positive. So we can use unsigned int because we are confident that the values cannot be the number of people cannot be negative, right? So we are going to use unsigned int to store all the positive value, large positive values, integers. Next is the constant value const. So we are going to use this a lot when we are talking about fixing our pin number in our ESP32 or Arduino UNO. So we are going to use this. So what it do is it is storing a value that cannot be fixed, that cannot be reset later on. You cannot change the value of this pin later on once you are when the program is actually executing at at that time. So you cannot change that. So this is one example of how you can use all these variables. So we will be looking into I'm not going to explain this in a very detailed way. These are more than sufficiently these values here. So this is how all the variables are defined in any of this program. Now next part that I want to explain you here is the how we write the structured code in the Arduino. So first thing we are going to do, I have already told you what exactly is set up. In whatever we write here is going to execute only once, so one at a time. So here we start basically with the serial.begin. So this is something that define what is the speed that we are going to talk about. So speed that we are going to talk. So this define what exactly is the speed that we are going to talk. So for example, if there is message that I want to print in the serial, what is the speed that it will be the data will be getting out from the system, and it should be there. So this is something we define using this serial.begin. So we are defining this is the speed at which the particular data will be coming out. So this is called baud rate. So exactly it says what is the amount of number of bits that would be coming out from your system. So that you should tell that the system that this is the speed, and you should also be listening at this speed, right? So this speed at what we are going to talk. Next one is the pin mode. So what it actually do is it defines what is the function. It defines what should be the function of the pin be like. So what it do is it is defining what should this exact pin should be doing. So we are defining that using pin mode. So using this we define how a pin should behave like. So here pin mode LED pin output. So the pin mode, this exact pin which is LED pin which is 2, we have already defined it. So pin number 2 should define or work as output. This is what we are defining. So similarly next one here using pin mode we are defining button pin which is on somewhere, I think let's see. So button pin. So yeah, so in the button pin here we have the button pin. So we have defined button pin as 2. So in the pin number 2 should defined as input. So whatever I give to this value, it should work as a pin number 2. Sorry, it should work as a input pin. So it should work as an input system. So whatever we defined here, should work as input. So what it is going to do work as an input. So this is how you can define a pin mode. So using this particular 2 things, you can define what a pin should work like. Next is a serial print. So we have talked about serial.begin. We have talked about what is the speed that we are going to talk. Now this is going to do what it is going to do. It is going to talk. So what it is going to do, it is going to talk. So this is actually the message that we are actually going to print in the terminal or print in the serial monitor. So this is the message that we want to print. So how we can do that? Serial.println. And basically it is serial.print. This is the actual way we message write the message in the serial monitor. But this is a special one where we got this ln extra part which says new line. So whatever we will be printing, for example Arduino variable example, then all of these will be printing one after the next line. So this is what it is going to do, and when we execute it you will see it. So this is how you can do the serial println and the serial print. So what these do is they print message. So they print message in the serial monitor. Right, so this is how you can define your LED pins, how you can initialize your code here, what is the speed that it should be talking about, and what is the speed that it should speak, and what should be the speed that your system will be listening to. So this is how we can initialize this, and this is the same way how you are going to print all of these. So this serial print, serial ln, and here you can see this is the first part where we are defining everything for that is needed to be executed one time, because we want our button to work as an output only one time. We want that to be fixed for entire process. So this is what we have defined here. Now this is going to be fixed for entire time. It is not going to change, or it is not going to. Now after the variables, we are going to understand the different other important parts. So I have already explained you some of the things, that is the setup, loop, what we actually do here. So whatever we put here is going to execute for one time. Whatever we put in the loop, it is going to execute for multiple times. Now we are also going to understand different other parts. So we are going to understand, we are going to start with the constant part. So here I have told you about the const int, right? So according to using that, whatever we put in that in this, it is not going to change in ahead when we are executing the code. So for example, we have constant LED pin which we want to be that to be fixed over the process or over the program execution. So what we use here is const int, particular value that we want to put here. So for example, if there is something that I want to put here that is needed to be changed later, then what I can do is directly use this one. So int, let's say some values, let's say temperature, which is initially I'm defining as 0. This is needed to be changed later, right? So what I can do here is, instead of going with constant, I can go with int only. So because I want to change this value later, it may change where this, it happened that this value may change later. So I can do that using int only. If I want this value to be fixed for entire time, then I will be using constant. So this is the best way you can understand it. But when we are talking about variables, so it can change later on. So for example, if I have button state, it may get 1, it may turn on, it may turn off. So it is going to change. So for example, sensor value, it may going to change, because sensor value, for example, if I'm using moisture value, then it is going to change over the time. Brightness, it may change. So whatever change, we will directly use int, then put it value here, and whatever is not going to change, we are going to use a const int. So it is going to constant for entire time. Now we are going to understand different part. So pinMode is something that we are going to start with. So first thing I want to explain you here is the void setup is already what I have done. And inside void setup, whenever we are starting, the first thing that we tell about our system or about to our ESP32, that what should be speed that it should be talking to about. So for example, serial.begin. So this is the speed it should be talking about. So for example, there is two person, one person talks very speedily or very fastly, and another person has less capability to hear that exact speed. So what we are doing here is we are defining this should be the speed that you should be listening and talking to. You cannot go above this or below this. So this is the speed we are defining here that we are going to talk. So this, this is start communication with the computer. So this exactly is a baud rate. So baud rate is something, the number of bytes that is coming out of your system at what speed. So this is how we define that speed. Next is a pin mode. In the pin mode, we got basically two different ways, that is input or output. So pin could have two different functionalities. So for example, if I want to use LED with my pin, then I can define the mode. What should be the mode of that particular pin where I want to add LED, because LED takes input. So LED takes input, and we require to give it output. So we are defining that pin to work as an output so that it can power on the LED. So to power on the LED, that particular pin should be output. So we are defining output here. So pin mode, that particular pin, whatever we want to call here. So let's say we have the the ESP32 pin, that is 2. So we can directly use this. So pin 2 should be working as output. So this is what we are telling here, explaining here. Next is the pin mode, again PWM LED. So if we want to control the brightness of our LED, then we will be using this particular pin, and we want it to work as output because LED required input and we needed to give it output. Next is pin mode, for example button pin, because button is input device. When we are pressing it, it is giving some signal to our pin, so it should be taking input. So here we have defined it as button pin should be working as input. So this is how pin mode works. So here we basically have two things, output or input. So based on your requirement, you can define whatever you want to assign it. So first thing should be pin, then next one should be output or input, so or whatever the input system you wanted. Next is the when we go into the the loop part. So we know that in the loop, whatever we do is going to run repeatedly for forever. So we have here void loop inside this. First thing we are going to learn is, we have already know the pin mode, right? So we know it should be input or output. What if we want to read digital some values from outside that may have 1 or 0? Then we can go with the digital read. So using digital read, we can only read two values, that is 1 or 0, either true or false, low or high. So this is the value we can read. So if we want to read any digital signal, that is whether a button is on or off, then we can go with this digital read. So it can read only digital pins and it returns only high or low. So using digital read function, we can use it to read digital signals. Next thing is digitalWrite. So using digitalWrite, what we are doing here is we are writing it outside. So if we want to give high or if we want to give low on the output as an output, then what we can do is digitalWrite. So what it do is it send a signal either 1 or 0 to the output. So this is how you can use a digitalWrite and digital read. So digital read is for taking output data, digital write is for giving output. Next is the analog read. So similar to digital read and digital write, analog read is for analog value reading. So it may happen that it is more than 1 or zeros. It may have 0 to 255, 0 to 1024. So that could be values. So if we want to read this values, that we are going to go with analog read. So once we use this function here, so analog read, what it is going to give us, all the value that may be more than zeros and ones. So this is what we are going to do. For example, if we want to use our moisture sensor, then it can have values of more than zeros and ones, right? So we can use analog read to get that exact value or the range of values that it is giving out. Next is analogRwrite. So in the analogRwrite, we are giving the output from a particular range, that is 0 to 255, 10, 0 to 1025, whatever the value we want to give it in output. So we can use analogRwrite to write that particular data in output. Next is the serial.print. So in the serial.print, what it actually do is it print a particular message in your serial monitor. So here we got serial.print sensor is equals to. So for example, if I want to put some message like this is the error that we are getting, or this is the line where we are getting this error, or this is the line up to which it is executed. So it will be giving us some message, or mostly it is used as a debugging tool to let us know that this is the problem, this is the issue that is happening. So this helps us a lot, and we are going to use this a lot of time. So here there are two different versions of it. So serial.print and serial.println. So the serial.print, normally what it do is whatever it is going to print, it is going in a forward way. So it is not going with the new line. But when we add the ln in the last of it, then what it is going to do, it will be printing everything in the new or next line. So this is what this makes everything much clearer or much cleaner compared to this one. So it will be making every data, all the data when very close to each other, and it will be very confusing if we are going with the numbers. So we are going with the ln. It will print everything in a line by line way. Next part is about here is the map. So mapping is something we are going to use a lot when we are talking about servo motors, when we are talking about robot arms. So we are going to use this function a lot. So using map function, what it actually do is it change particular range to a particular range. So for example, if we want to convert, let's say, one range to another, then we can use this particular map function. So let's say we are getting a potentiometer value of 0 to 1023. And if we have a potentiometer, let's say this is a potentiometer. If we are rotating this potentiometer, we are getting a value of 0 to 1023. And we want to convert these values into speed for our Arduino to convert into speed for the DC motor. And based on this regulator position, or based on the rotation I'm doing here, I want to increase the increase the speed of the DC motor. Then we can use this exact way. Using map function, we can convert that particular value to work as an speed or some other value range. It should be working as some other value ranges. So this is how we can do using map function. So this is one of the example how you can use, and these are the different ways how you can use this different stuff around. And these are the one or multiple examples here that you can use in your programming, Arduino programming and ESP32 programming. Well, you don't require to remember all of these. Most of the time, all of these what I am explaining here is just for your basic understanding, that whatever you are getting from a Claude or your ChatGPT or AI, whatever you are doing, you should understand that what each of these lines should be doing. So this is what I really want, this is why I really want to explain you all of these. So this is a modern time, all of us have the AI power, so we can use the ChatGPT directly, but we need to understand what exactly is going behind all of those. So this is why I want to explain you all of these lines, and there are multiple hundreds of other things around. But what I am explaining you here is all the basics. Over the time, once you get all of these, you can understand all of those also. So over the time, when we are going with the explication part, then I will explain you each of this code line by line. And once you understand each of these, you will it will make you much better developer compared to those who don't know anything about all of these, and they are just throwing prompts to the AI and getting the output. If I ask them do this part, make changes in this part, they will feel embarrassed, or they will again go to the ChatGPT and they again do that. And most of the time it happens that it makes some mistakes around. And if you don't know nothing about your system or how everything is going behind it, then it is going to cost you a lot. So these are the things that I want to explain here. These are the things that you should know about before programming an ESP32 or an Arduino. So these are the things that I want to explain in this exact video. After this video, we are going to see some of the application. We are going to start with basics of actuators, basics of servo motor, DC motor. We are going to connect some of the sensors around. I will be explaining all the codes to you line by line, and we will be executing all of the code in the ESP32. So in the next lecture, I want you to have the ESP32 in your desk and be ready with your all the setup that I have done here. And I will be also showing you some of the sensors here, some of the actuators. If you could afford it, then please do have that in your desk. And you can just if you can't afford it, then just watch these videos around and you will get the basic understanding of how all of these are going. So this is all about this video. If you're liking my content, then please do consider subscribing my channel. This take a little effort from my side, so please do consider like subscribing, sharing if it is possible. So this is all about this video. See you next time. This is Vikas. I love robotics. Till then, bye.